You are a volunteer that rescues reptiles, turtles, snakes, and lizards that are in the unlucky position of living in the path of new construction. Typically, in these cases, animals move. They search for new homes and food sources nearby. However, eggs cannot crawl, slither, or swim to another location, and construction projects will not wait for eggs to hatch. You've talked with the construction workers and with a nearby reptile conservation center. The workers are willing to notify you when they come across reptile eggs. The center is able to incubate the eggs until the babies hatch and then return them to the wild. Your role is to design a reptile egg incubation device that keeps an egg warm and safe as it is transported from the worksite to the reptile conservation center. Reptile eggs are leathery and soft. While they are not prone to crack easily, they need to remain in the same orientation they were originally laid. Whatever is facing up must stay facing up. They cannot be flipped, turned, or jostled. Very importantly, the eggs must be kept warm, but not too warm to properly develop and hatch. You have a job to do before the first batch of eggs is found. Design a temporary and portable reptile egg incubator device that will keep one egg warm and properly positioned while you take it to the Reptile Conservation Center. Let's give these young lizards, turtles, and snakes their best chance at life. From your pre-lab review videos about endothermic and exothermic reactions, maybe we can take a page out of the science behind hand warmers and use the idea of a hand warmer as the heat source for your incubator. Now, you have to control the temperature, so there are some things that you have to take into consideration. Projects have criteria and constraints. The first one, criteria, these are the things that the project, or in our case, the device, must have. That's called criteria. So as you think about your incubator, what are the things that it has to have? What is the criteria? The other side of that is constraints. And what are the possible things that could go wrong that you might need to account for? So take a minute, you can pause the video to complete part one, and if you need to go back and look at the previous two slides about criteria and constraints to see what the questions are, you can do that as well. Fill in part one of your lab report. You have received a text from the construction site that they have found some eggs. So you can see the text right here on the screen. So use this information and the information on the following slides to determine what type of eggs you have. When you're ready, pause the video and complete part two on your lab report. Now that we know what the eggs are and the temperature range that we're shooting for, let's do some experimenting with some chemical reactions to see if we can find a reaction that will get us in that target range to keep our eggs warm in the incubator. Calcium chloride and water create a simple chemical reaction that produces heat. So for our first two experiments, we're going to see what kind of temperature it can provide with this basic reaction. As you see here, my materials that I'm using are a couple of cups, a thermometer, and for every experiment we will be using 15 milliliters of water. For each experiment performed, you will be recording the data on your lab report. So you can pause, record the data, come back to the next one if you'd like. Here's the first one, and as you'll see, we have a quarter of a teaspoon of calcium chloride. Again, there's 15 milliliters of water that's used every time. We have an initial starting temperature. And now what I'm doing in this first one is I'm adding the quarter teaspoon of calcium chloride. And then I will put the thermometer back in and let it simmer, if you like, to get the optimum temperature for this reaction. This will be the same procedure for each of the experiments that are performed. So here's experiment number 2. So calcium chloride seems to be a good chemical for the heating part of our heat pack design, but is there something that maybe we could add to the mix that might give us a little cushion to protect the egg? Absolutely, baking soda. But how will the baking soda affect the temperature in the chemical reaction? That's what we need to determine. So our next set of experiments, and there are 4, will be a different combination of calcium chloride and baking soda. Again, it's still 15 milliliters of water. The procedure will be the same. You'll be collecting the data, amounts, and the temperature. And at the end of this set of 4 experiments, we'll reevaluate and look at it again. Since adding baking soda does make the temperature go down some, does this mean that it shouldn't be used in the design of our device? Not necessarily. Maybe it can be used so that the gas is produced, but with enough calcium chloride to make the temperature high enough. There would need to be some kind of balance between the amount of calcium chloride and the baking soda so that the right temperature is reached, but enough gas could be produced to hold the egg in position and maybe give it a little bit of cushion and protection. So what we're going to do is we're going to repeat the 4 previous experiments with the same amounts, but this time we're going to use a sandwich bag as our heat pack design. So you're going to make some observations about how the bag inflates, deflates, does it have enough, does it not have enough. You're going to write down some observations on your lab report, and then we'll come back and reevaluate from there. Before pausing the video to complete part 3 and making your heat pack combination decision, here are some things you might want to think about in making that selection. You might have decided what the ideal temperature is and maybe the bag inflation, but how is everything else going to be affected in that process? So when you're ready, pause the video and complete part 3. And now the fun part. You get to try your hand at building an incubator for your egg to protect it during transport. All the instructions are on your lab report. And remember, have fun!